The Richat structure, also called Guelber Richat, the Eye of Africa, or Eye of the Sahara, is a prominent circular feature in the Sahara's Adrar Plateau, near Ouaddaine, west-central Mauritania, northwest Africa. It is an eroded dome, 40 kilometers (25 miles) in diameter, exposing sedimentary rock in layers which appear as concentric rings. Igneous rock is exposed inside, and there are spectacular rhyolites and gabbros which have undergone hydrothermal alteration and a central megabreccia. The structure is also the location of exceptional accumulations of Acheulean archaeological artifacts. The Richat structure is a deeply eroded, slightly elliptical dome with a diameter of 40 kilometers. The sedimentary rock exposed in this dome ranges in age from late Proterozoic within the center of the dome to Ordovician sandstone around its edges. The sedimentary rocks composing this structure dip outward at 10 to 20 degrees. Differential erosion of resistant layers of quartzite has created high-relief circular cuestas. Its center consists of a siliceous breccia covering an area that is at least 30 kilometers in diameter. Exposed within the interior of the Richat structure are a variety of intrusive and extrusive igneous rocks. They include rhyolitic volcanic rocks, gabbros, carbonatites and kimberlites. The rhyolitic rocks consist of lava flows and hydrothermally altered tufaceous rocks that are part of two distinct eruptive centers, which are interpreted to be the eroded remains of two maars. According to field mapping and aeromagnetic data, the gabbroic rocks form two concentric ring dikes. The inner ring dike is about 20 meters in width and lies about 3 kilometers from the center of the Richat structure. The outer ring dike is about 50 meters in width and lies about 7 to 8 kilometers from the center of this structure. 32 carbonatite dikes and sills have been mapped within the Richat structure. The dikes are generally about 300 meters long and typically 1 to 4 meters wide. They consist of massive carbonatites that are mostly devoid of vesicles. The carbonatite rocks have been dated as having cooled between 94 and 104 million years ago. A kimberlitic plug and several sills have been found within the northern part of the Richat structure. The kimberlite plug has been dated to around 99 million years old. These intrusive igneous rocks are interpreted as indicating the presence of a large alkaline igneous intrusion that currently underlies the Richat structure and created it by uplifting the overlying rock. The Richat structure is regarded by geologists as a highly symmetrical and deeply eroded geologic dome. It was first described in the 1930s to 1940s, as Richat crater or Richat buttonhole, boutonniere du Richat. Richard Mollard 1948 considered it to be the result of a laccolithic thrust. A geological expedition to Mauritania led by Théodore Monod in 1952 recorded 4 crateriform or circular irregularities accidents crateriforms ou circulaires in the area, Richat, Ouelloul, south of Chinguetti, Temimichat Galaman and Tenumar. Origin of Richat as an impact structure, as is clearly the case with the other 3, was briefly considered, but closer study in the 1950s to 1960s suggested that it was formed by terrestrial processes. After extensive field and laboratory studies in the 1960s, no credible evidence has been found for shock metamorphism or any type of deformation indicative of a hypervelocity extraterrestrial impact. While cosite, an indicator of shock metamorphism, had initially been reported as being present in rock samples collected from the Richat structure, further analysis of rock samples concluded that barite had been misidentified as cosite. Work on dating the structure was done in the 1990s. Renewed study of the formation of the structure by Matten et al. 2005 and Matten 2008 confirmed the conclusion that it is not an impact structure. The circular distribution of ridges and valleys is explained as the formation of cuestas by the differential erosion of alternating hard and soft rock layers uplifted as a dome by an underlying alkaline igneous complex of Cretaceous age. A 2011 multi-analytical study on the Richat megabreccias concluded that carbonates within the silica-rich megabreccias were created by low-temperature hydrothermal waters, and that the structure requires special protection and further investigation of its origin. The Richat structure is the location of exceptional accumulations of Acheulean artifacts. These Acheulean archaeological sites are located along wadis that occupy outermost annular depression of this structure. Pre-Acheulean stone tools also have been found in the same areas. These sites are associated with rubbly, chaotic outcrops of quartzite that provided the raw material needed for the manufacture of these artifacts. The most important Acheulean sites and their associated outcrops are found along the northwest of the Outer Ring, from which Wadi Akartal heads east and Wadi Bamouer to the west. Sparse and widely scattered Neolithic spear points and other artifacts have also been found. Artifacts are found, typically redeposited, deflated, or both, in late Pleistocene to early Holocene gravelly mud, muddy gravel, clayey sand, and silty sand. These sediments are often cemented into either concretionary masses or beds by calcrete. Ridges typically consist of deeply weathered bedrock representing truncated Cenozoic paleosols that formed under tropical environments. The Pleistocene to Middle Holocene sediments occur along wadis as thin, meter to less than meter thick accumulations in the interior annular depressions to 3 to 4 meters thick accumulations along the wadis in the outermost annular depression of the Richat structure. The gravelly deposits consist of mixture of slope scree, debris flow, and fluviatile or even torrential flow deposits. The finer-grained, sandy deposits consist of Aeolian and Playa Lake deposits. The latter contain well-preserved, freshwater fossils. Numerous, concordant radiocarbon dates, indicate that the bulk of these sediments accumulated between 15,000 and 8,000 BP during the African humid period. These deposits lie directly upon deeply eroded and weathered bedrock.